calibration framework for ROS, and in this case we are going to look at the playing back data from an atom dataset, and in particularly inspecting and correcting 3D LiDAR modality data. Okay, so first we are using the LARCC robotic system, which has a lot of sensors, so we are going to hide most of the things that we are seeing here, so we don't have to see the TFs nor our robot. This is not important, and we can hide also the cameras as well as the depth information. So now let's use, for example, just LiDAR 1. We need to label one at a time, of course, and you can see here that this is the point cloud that was taken for collection 0, and if we want another collection, we can go to the right arrow, and we have here the next collection, and still the next, and so on and so forth. We have many collections here. Okay, the idea is that you go through all collections and you try to do more or less detailed inspection, trying to figure out if there are wrong annotations. For example, in this collection here, we can see the following. First, the conventions. The gray points are all the points from the LiDAR data for that particular collection, and the green spheres that you see there are spheres that are annotated as LiDAR points that belong to the pattern. Okay, so all of those that you see here are actually belonging to the pattern, which is this object here, which is in front of the sensor. But you can see that not all of the points here are actually being annotated as belonging to the pattern. So that's one thing we could correct, although that's not the most critical one. The second one has to do with the following. So the second convention is these green dark points that you see here, and these are meant to be annotated only on the boundaries of the pattern. Okay, so these are the boundary points, point annotations. And the biggest problem that I see here is that we have there, where my mouse is, a dark point, meaning that that's the boundary, the annotated boundary, and this is clearly a mistake. Okay, so let's try to correct this labeling. How can we do it? For that we are going to use a tool called Selected Points Publisher, which you should have on your RVs if you have compiled the atom. Just compile your Catkin workspace after cloning atom, and now we look for a good position from which we can see the points. This is never. Sometimes this is not easy, especially for LARCC, which has so many points, so many sensors. But perhaps, oops. Okay, not like this. Perhaps like this. Okay. So, as I told you, first let's get rid of that bad annotation there. That's the biggest problem now. So we can just select some points and then just remove with R. Take a look. Now we don't have that point annotated as a boundary. Also these two we can remove. Actually, these three, remove. And now what we have to do is to annotate all of the points that belong to the pattern as points belonging to the pattern. So I'm just going to try to select a lot of them and press P for publish. These points are belonging to the pattern. P, P. I'm just doing several selections, trying to be able to select them all. Okay, almost everything is green, so that would be a good annotation. All we need now is the annotation of the boundaries. So we still have here some additional points. I'm going to zoom in. Okay, and now going back to the select points publisher, I can select one by one, for example this, and then shift and select another, and another, and another. And these points are boundary points, so I press B. All right. Now I go to the other side, and I'm just going to select the points that are missing. In this case, I think that's the only one, so B. Okay, and this is a good annotation of a 3D LiDAR data, which was improved, corrected, and this is what the user should do if and when there is there is no trust that the automatic system is correctly picking up the pattern. Of course, then I would have to do this for the other sensors. For example, I can go here to the data of the second lidar, which perhaps would also need correction, and then for the other collections. Okay, that's it. Thank you.